Hello students, welcome back. In this video, we are going to focus on a very popular encryption algorithm called as the data encryption standard. Although this algorithm is not used currently commercially, but this algorithm laid the foundation for many other algorithms to follow. Right, so we'll start with data encryption standards architecture, main functional diagram, and then we'll see how this works. This is going to be a longer video, so what I will do is I will try to break it up into multiple parts so as to focus on the various topics individually in depth. Right, so let's start with the conceptual view of what DES is. As you can see on your screens, the data encryption standard looks like this. So basically what happens, it accepts input of 64 bits in size. So this is a fixed size input, that is 64 bits. When this input goes inside the DES block, it is encrypted using a 56-bit key. Now the very first question that would creep in your mind is, if the plain text is of 64 bits and the key is of 56 bits only, then how we can compute the encrypted text? Because we have seen in the previous videos that the size of the key and the size of the plain text should be equal so that we can do some sort of operations. The very basic operation that we saw was XOR. So don't worry, we'll see in detail how the 56 bits are used to encrypt the 64 bits plain text, right? So at the end, we get a 64 bits ciphertext. So this particular process keeps on going until we encounter the last block of the 64-bit plain text and the corresponding 64-bit ciphertext is generated. So now let's focus on how this particular thing works actually. Let's see the very first block diagram, or we can say the architectural diagram of DES looks like this. Although the internal architecture diagram is much complex as compared to this, because this is just the conceptual view of what DES looks overall. Okay, so this is how the things work. The 64-bit plain text goes through a process called as initial permutation. Now, what exactly is initial permutation? As we have already discussed what exactly is permutation. Permutation is basically a process where we are changing the position of the plain text bits. So for example, if the first value is A and second value is C, if we apply a permutation of 20 over here and 17 over here, then what happens is A goes to the 20th position and C goes to the 17th position. So what we are doing is we are basically permuting the positions of the plain text. That is what happens over here in the very first step. How it is done and what output is expected, that we will learn in detail in depth later on. Fine. So this was just the introduction of what permutation is all about. Next, what happens is the next step is what we call as left plain text and right plain text. Now I hope you are familiar with this because you have already seen the video on Feastal architecture or Feastal cipher. If you have not yet seen that, I would request you to kindly go back and go through that video in detail, because that lays the foundation for data encryption standards. So what exactly happens is, after the initial permutation, we get the same 64-bit value, but the positions will be interchanged. Now that 64-bit value goes through a Feastal architecture kind of structure, where what happens is that particular plain text is further broken down into two parts, the left plain text and the right plain text, as you can see over here. Let me show that quickly for just reference. Over here, what you can see is this is the Feastal architecture. The left and right plain text goes through n number of rounds where the left and right plain text are swapped and some operations are being performed on that. So this is how the Feastal architecture looks like. The same architecture is going to be followed over here in the case of DES as well. But over here, the value of n is fixed, that is 16. So there will be 16 such distinct rounds of the Feastal architecture that will be performed on this plain text. And once the 16 rounds are done, we will get some value. That value is nothing but, if you remember, we are going to get the LPT, that is left plain text, dot RPT, that is the right plain text. So this will be 32 and this will be 32. So in total, we will be having a 64-bit ka ciphertext. That ciphertext basically goes through a process called as final permutation. Now this final permutation is again quite similar to what we did in initial permutation. Again, over here we'll perform the similar kind of an operation, but with a different arrangement of keys. As we saw in the previous case, A was going to 20th and C was going to 17th and so on. In this case, what will happen is we'll do similar kind of an operation, but the numbers or the arrangements might be different. For example, A might go to the position 0, 8. So A might go to 8, C might remain in 17th, and so on. I'm just taking some very basic examples using which I hope the concept will be clear in your mind, right? So that's how the DES works, but it's not that simple as it seems. It is a little complex, but I will try to make it as simple as possible. So that was all about the introduction to DES. In the next video, I'm going to start with the actual working and the process of all those rounds which happens inside DES. So stay tuned. Take care.